Welcome back to the 19 Days of Python Challenge by Newton School. So, today we are showing you how to write powerful one-liners with Python's Lambda function feature. So, short, simple, and super useful. So, let's get started with today's lesson.
Yeah, now important thing, lambda function. So a lambda function is a small anonymous function. Its length will be very small, defined using the lambda keyword. So till now we were using the def keyword. Now we are using the lambda keyword, and lambda functions are generally used for the short simple operations, for the short operations. So let's see, its syntax is just like, you no need to use def, you use lambda, then you give the arguments, whatever arguments you want to give, and then the expression, the code, right? Let's see. So lambda functions are like, coffee breaks in Python. You don't need a full function. It's just like a sip of a coffee, right? Sip of a code, right? So a lambda function is just act like a quick recipe that you can prepare in just few steps. So let's see how it works. So let's say you don't have time to chop vegetables, but you still want to make the sandwich. You can take just 2 slices, just spread, use the sandwich spread and do it. So lambda functions are very small for the small work you want to do, right? So let's see how it works. So the syntax was, you can use lambda, then arguments, and then expression. See, so we have used just lambda, the arguments, and then the code. That's it. So for example, when we want to write the code for sum of 2 numbers, how was that? Let's say there is a code sum, it is taking a comma b, and let's say then it is returning a plus b. And if I want to call this sum, what will happen? Let's say I want to call this with 4 comma 5. It will print 4, it will return 4 plus 5, 9, and we are printing result. But if I want to return it using lambda expression, how you can do this is, you can simply say result is equal to lambda. So lambda is a function. You are just writing it in a single line, lambda, and then you need 2 arguments, a comma b, and then what is the logic, what is the expression you want to do on that particular argument? You want to return a plus b, right? So this is nothing but a function, and what will be the name of the function? You have to give it before equal to. Let's say the name of the function is again sum1. Now you can just call this function. So you can call this function sum1 with 2 arguments, 4 comma 5, right? You can do it in the same way, equal to sum1 4 comma 5. So what will happen? It will again print 9. So let me just comment this code. For you. So if you just see this is a lambda function with the name of the function is sum1. Lambda is the keyword, then these are the arguments, and this is the output. That's it. So if we call this sum1 with 4 comma 5, it will return 4 plus 5, which will be 9. If I call it with 4 comma 8, it will return 12. So lambda functions are just like the shorthand functions. It is like we are using the lambda function for the short simple operations. That's it. Now functions and if else conditions, right? So the functions and if else conditions are like a recipe with choices. So when you are using a function, just like a normal code, whenever you write a program, function is also like a small part of your code. So whatever you can do in a program, you can do it in a function. So in a function, you can use if else statements, right? For example, this is your function, def, check age is the name, and age is the argument, parameter. And inside it, you are using conditions, using conditionals inside function. So if age is greater than or equal to 18, return adult, otherwise return minor. So return is nothing but the function is returning something. So a user-defined function allows you to define the function that can include if-else conditions as well, right? So function is just a small machine out of the big machine, which is your complete program. That small machine can have any type of code, as simple as that, right? Similarly, if you see lambda function, so if you say lambda, then age is a parameter, right? If you see this, before colon, it's parameter. Age is a parameter. Then what we are saying, adult if age is greater than or equal to 18, else minor, right? So this is like in a single line. So in the lambda function also you can use if else, right? In the lambda function also you can use if else, right? Now what are recursive functions? Recursive means one after the other, right? So for example, whenever we have a function, let's say we have a function which has a piece of code, so we can call it anytime, right? Let's say we call it, it gives us some output. Let's say we call it, it gives us some output. Simple. What if that call is happening inside the function itself? Let's say this is the function and inside it there is a logic, but there is a statement inside the function itself rather than some other code calling it. There is a statement which is calling the function itself. So calling the function inside itself is called as recursive function. We are calling the function inside function, right? So a recursive function is like a set of Russian dolls, right? Each doll contains a smaller doll and so on, right? And then to reach the smallest doll, you have to keep unpacking the dolls. So let me explain that as well. So let's say in a function there is a code, and inside that code you are calling, and then there is another code as well. Here you are calling the function itself. So what will happen? The call will go here. Will these statements execute? No. Then let's say the second call is happening. The first call came from somewhere, and then inside function you call the same function. Then the second call comes. Then you call it again. Then you call it again. Don't you think it will go infinite? The call will go infinite. The functions will go infinite. But this is not right. Otherwise, your code will never come to an end. Your code will never come to an end, right? So to stop this, there should be some condition. There should be some condition which is called as base case. So there should be some condition to stop that recursive calls. So let's say that condition met, and then you end the recursion. So you go back, and once you start going back, this code will start executing, right? So it's as simple as, you just see. So let's say from some place you are calling a function, and in that place, for example, in this code, we were doing the print of result as well, right? But till the time this function will not execute, will this print execute? No. So till the time function will come back, we cannot execute further steps, right? So this function has to return, and then rest of the code execute in the program. Similarly, in the recursive code as well, if the function is calling itself again, till the time the call comes back, the rest of the code will not execute. As simple as that, right? So that's what I wanted to talk about recursive functions. So let's see it with an example. So there is an example of factorial, right? You know factorial, right? So 4 factorial is 4 multiplied by 3 multiplied by 2 multiplied by 1, right? And what is 0 factorial? 1. So I hope you already know this with the mathematics. So a recursive function is a function that calls itself to solve a problem, right? Recursion is typically used for the problems that can be broken down into smaller subproblems, right? So for example, for example, let's say you talk about factorial. Let's say you want to find out 4 factorial. What is 4 factorial? 4 multiplied by 3 multiplied by 2 multiplied by 1. What is the answer? 24. Can we say 4 factorial is nothing but 4 multiplied by 3 factorial? 3 factorial is 6, 6 into 4. Can we say 3 factorial is nothing but 3 multiplied by 2 factorial? So can we break this problem into smaller problems? So because if I know 3 factorial, I will be able to calculate 4 factorial. So you can actually break this problem. So that means you can use recursion. That is one thing. So recursion is generally used when the problem can be broken down into smaller problems. Now, how we can solve this is how we can solve this factorial using recursion. So let's say I want to find out 5 factorial. Inside the factorial function, let's say you have a function where in this particular code you are able to find the n factorial, right? So can you say that you can just call this function to find out the factorial of n minus 1 and you multiplied it by n and that thing you can return. So if you see carefully, we are actually using the recursive function. We are calling the same function with the different parameter. Earlier we called it with n, now we are calling it with n minus 1. Why? Because if you take the example of factorial of 5, you can say it's nothing but 5 multiplied by factorial of 4. You can say this is nothing but 4 multiplied by factorial of 3. What if you keep on doing it? What if you keep on doing it? Let's see. Factorial of 3 will be 3 multiplied by factorial of 2. Factorial of 2 is 2 multiplied by factorial of 1. Right? And then factorial of 1, if you keep on doing it, what you will do is 1 multiplied by factorial of 0. And then if you keep on doing it, what will happen? You will say 0 multiplied by factorial of minus 1. Does this make sense? If you will do, does the factorial of minus 1 exist? No, right? So somewhere you have to stop the recursion here. This is here you have to use base case. This is where you have to use the base case. So if you simply see the function, how it works is, we are using df factorial, n is the input. So we are making the recursive call, we are returning n multiplied by factorial of n minus 1. And as soon as the base case reached, if the n becomes 1 or 2, you are simply returning 1. So that the recursion will keep on going back. Recursion will keep on going back. So if you try to do this, right? If you try to see how this code is working, so let's say you call this function with value 4, right? Let's say you call this function with value 4. Is n 1 or 0? No. So you are calling it again with 4 multiplied by factorial of 3. You are calling it with 4 multiplied by factorial of 3. Right? Then the call will go back. To the same function. Is n 1 or 0? No. Then it will again return. What it will return is 3 multiplied by factorial of 2. Factorial of 2. Is n 1 or 0? No. So what it will return is 2 multiplied by factorial of 1. Now for this particular call, is n 1? Yes. So we will return 1. We will return 1 to whom? If this call will go, this will return 1. 1 back, right? And as soon as we got f of 1, factorial of 1 to be 1, then the factorial of 2 will return, because it was already into the else condition. It will return 2 multiplied by 1, which is 2. Then this will return 3 multiplied by 2, which is 6. And then this will return 6 multiplied by 4, which is 24. So this is how recursion works. So this is nothing but recursive function. Now what are nested functions? Nested function is nothing but that is defined inside another function. So a function can have the definition inside another function itself. For example, this is your outer function, def, outer function, a and b are the parameters. And then we have inner function which you can actually use inside the body of outer function itself. For example, you have an inner function which returns the sum of two numbers. Now you can use this function inside the outer function only, right? You can say result is equal to inner function a comma b return result, right? So you call the outer function with the parameters, then you already have the inner function, which is just a function. Without calling the function, it will not execute. Now inside the outer function, you are calling the inner function with parameters, whatever you got. It will go, a and b will go here, it will return the sum, and then it will return the value, right? So a nested function is nothing but function inside function. So you want to write some logic as part of the logic of a outer function, right? So yes, these are again some of the memes related to functions that signifies how important these are, right? Let's go to the quiz time, right? So again, whenever the question comes in, pause the video, think about the solution, and then move ahead, right? So what will be the output of this code? We have an add function where x is there and y is equal to 5. We are returning x plus 5. This is a function, right? I hope you know what is y is equal to 5. Let me show that. You remember this default parameters? You can give using the equal to keyword, right? This we can edit in between. So we are having x and y is equal to 5, right? The default value of y is set to be 5. Now we are saying print add of 2. So we are just passing a single parameter. So y will remain default, and we are returning 2 plus 5 is 7. Equal to add of 2 comma 5. Here we are passing the y to be 5. So when there is default parameter, you can pass it or you can ignore it. So it will be equal. So it's true. Now there is a function make tea where we have water, default value is hot, and leaves, the value is none. So if leaves is none, leaves is green, and otherwise we are returning, if the if block will not execute, we are simply returning f of water, the value of water, this water, then we have a string water with, then the value of these leaves, tea leaves, right? So we want to call this function with leaves value to be black. So we are passing it to be black, right? So is leaves none? No. So what will happen is hot water with black tea leaves, hot water with black tea leaves. Because we are passing the value of the leaves, we are passing it to be black, right? So now we have a function calculate sum, which is taking the two parameters a and b, and we want to print a plus b. This is not returning anything. This function is not returning anything. So we are having result is equal to calculate sum 5 comma 3. What will happen? It will go here. It will print 5 plus 3, 8. 8 will be printed. And then we want to print result as well. What will be the value of result? Is it returning anything? So if the function doesn't return anything, the value will remain none. So it will print 8 and none. The result will remain none. Got it? Great. Let's move to another problem. here we have a function called multiply which has parameters x and y, and we are taking the multiplication of it and setting it in another variable called product. So we are calling print function with multiply 4 comma 5. Is 4 comma 5 returning something? No. Is multiply returning something? No, it will be none. So we are saying print none. We are not passing any string. So what will happen? No return statement, right? So the error in this function is no return statement. If there is no return statement, the print function will not work because print needs something to print, right? So it will bring out none, but print actually needs a particular string or the data to print, right? Now the scope in functions. So this problem is related to scope. So we have a message, hello world. This is a variable outside. Then we have a function, change message, and inside it we are reinitializing message to hello Python, right? We are changing the value of message. Now we are calling the change message first. What will happen? Message will become hello Python. If we print message, what will be the output? Hello world or hello Python? Let's see. So it will be hello world, because whatever you change in the function will remain in the scope of the function itself. That value will not be impacted outside. If the function call is done, we have changed the value of message inside it. That message was in the scope of function itself. That will not change the outer variable message, right? All right. So now you have mastered the functions as well. The next video will be on loops, and that will be very interesting topic because loops are very important when we want to do the same task again and again. For example, if you want to calculate, like we just learned about functions, right? So in functions we were doing some logic and we can reuse it. For example, we want to find out if the number is even or odd, right? So that's where the functions can be used, right? You can write the function, you can reuse it, whatever you want to do. But loops are the part of your code where you want to do some task again and again in a repeated manner, right? For example, if you want to print the number 1, you can write print 1. But if I ask you print all the numbers from 1 to 1000, will you write the print statement 1000 times? No, right? So that's where the loops will help. We'll understand that in detail into the next class. We'll deep dive into how the loops will automate some tasks for you without writing the lot of code for you. So yes, I hope you have understood the functions. Thank you so much for joining. See you in the next video.
That's how you write cleaner and faster code. We hope this video made Lambda functions easier to understand. If you have been coding along, drop a comment below. We would love to hear your thoughts.